The pride of European AI, Mixtral AI, released another random magnet torrent link. And I will say these are my favorite kinds of releases from Mixtral, because whenever they do this, it's generally their most impressive work compared to anything they've released before. And what they released this week is no exception. So of course, we got another kind of random torrent link, and immediately everyone jumped on this. Frankly, the marketing is brilliant. And this time it gave us Mixtral 8x22B, which is a 176 billion parameter mixture of experts model that is absolutely incredible. And we finally have benchmarks to see just how incredible it is. So in short, it's a 176 billion parameter mixture of experts model with around 40 billion active parameters when you invoke. Its context length is even larger than the last Mixtral 7B base model that was released at their hackathon, with over 65,000 tokens of context length. This model can be fine-tuned. Right now, it requires a staggering 260 gigabytes of VRAM in FP16 and 73 gigs in Int4. And I'll get into just a bit later how you can actually fit this onto a single H100. But I will say it's impressive that this is one of the first models we've gotten from Mixtral that even in its smallest quantized format isn't even close to fitting on something like an RTX 4090 or even an A100, which is pretty crazy. It uses a really similar tokenizer when compared to previous models we've gotten from Mixtral, and it's one of the coolest models we've seen yet. The performance is incredible. We finally have benchmarks to prove this up, and I can't wait to get into this in this video. I'm gonna go over kind of why this model is important, what differentiates it from previous models from Mixtral AI, and then I'm gonna run the full model at basically as large a size as I can fit on GPUs provided by Hyperstack. And I'm really excited to talk more about their hardware, their platform, and why I've been using it as my sole source for GPUs for this channel. So welcome to AI Flux, let's get into it. So this new Mixtral 8x22 model is expected to outperform any previous model released by Mixtral. Mixtral 8x7B, when it was released, was seen as a huge step forward, and Mixtral 8x22B is no exception. Many experts think that this model will actually compete with the likes of Llama 2, potentially even Llama 3, which we might see later this month, and explicitly OpenAI's ChatGPT 3.5 and even GPT-4 in a few areas. What's cool is this shows that the money that Mixtral AI has been ingesting is actually doing something. They raised about $415 million in December, and unlike Stability AI, who's been skipping out on their GPU bills, Mixtral AI clearly is still pushing ahead, and they're valued at north of $2 billion to date. And the competitiveness of this model isn't too surprising, given that Mixtral was founded by AI researchers that were previously at Google and Meta. So without question, this model is massive. The RAM requirements are larger than anything we've seen from Mixtral before, although we haven't gotten an official kind of non-leak release of Mixtral Medium. But what's interesting is, in theory, you can fit this onto a single GPU. However, the size of that is pretty interesting. So Daniel Han, I think, has one of the most interesting takes, ripping this model apart and how you can run it from the beginning. It uses the identical tokenizer to Mixtral 7B, which is pretty cool. What's interesting is the base model for this is significantly larger than Mixtral, which points to, in theory, much greater performance. The 16-bit precision needs around 260 gigs of RAM. Currently, the 4-bit quantization requires 73 gigs. And the HQQ 4-bit attention model and 2-bit MLP require only 58 gigs of RAM, which means that for reasonable performance with a model this big, along with having enough RAM, means you can fit it into a single H100. And I'm going to be doing that later in this video. What's also cool that Daniel mentioned is it already supports Unsloth's AI long context support, which is incredibly cool. Now, since this was released so soon, there actually isn't an official Hugging Face card, but I do like to go over what we have so far. So right now on Hugging Face, there are a number of models available. These are all in the Mixtral community, so it's actually a kind of unofficial page here. But there is the original, there's the 4-bit quantization, there is an AWQ model, and there's also recently been a GGUF version that's been released. Per usual, running these models is actually pretty straightforward. And what's great is this model has already been modified to support the Hugging Face Transformers format, and along with all of the various precisions we would like. So for instance, float 16, 8-bit and 4-bit, and it even has that support for Flash Extension 2, which is pretty cool. Per usual, Mixtral 8x22B is a pre-trained base model, so it doesn't have any moderation mechanisms, which in theory makes the benchmarks, I think, much more accurate, but it does mean you have to be kind of careful what you ask it. But we're going to be very reasonable since we're on YouTube. So let's look at what the benchmarks are telling us. So these were released very recently, and the results are pretty incredible. So right here, you can see we have Mixtral 8x22 base. And Cohere has released Command R recently. Qwen 1.5 has also been immensely impressive given its size. And what's crazy is, obviously, this isn't necessarily as performant as something like Cloud 3 Opus or GPT-4, but it's very, very close. And mind you, this is a base model that hasn't really been fine-tuned or heavily modified. So you can see that Mixtral 8x22B reaches about 89 on HelloSwag. And I think we should give a lot of weight to MMLU, just given how pervasive this benchmark is. And it scored around 77 with MMLU, which is actually higher than Cohere's Command R and well above Mixtral 8x7B base. So I think the biggest takeaway here is it's clearly better than Mixtral 8x7B. It's already beating Cohere's Command R, which was for some reason touted as kind of the next great generalized model, which I thought was kind of interesting. It's handily outperforming Qwen 1.5, and it'll be interesting to see with modification if we get even closer to reaching GPT 3.5 or even 3.4 performance. I think we're handily past GPT 3.5, which is wild to think about with how much progress we've made even just in the last few months. So now I want to get into how I'm going to run this. I'm going to give you guys some information on Hyperstack and why this is my new favorite GPU platform to do this stuff on. And by all means, let me know in the comments if you want to see other GPU content like this. I might also start doing some fine-tuning tutorials. And what's great is I actually have access to, 8x8 machines now, which is pretty cool. So let me know in the comments. Let's hop over to Hyperstack. So usually I just use my local 4x4090 machine. However, for the stuff I've been trying to put together for the last few weeks, I've needed some more powerful GPUs. And fortunately, Hyperstack reached out a few weeks ago, and I've been working with their platform pretty extensively. There are a few reasons I prefer this to Amazon or Lambda, and some of those core reasons are that Hyperstack is one of a very few NVIDIA elite partners. Basically, they have the best access to NVIDIA's latest hardware, both in networking and GPUs. And this is why Hyperstack is actually going to have the earliest access, or some of the earliest access, to NVIDIA Blackwell GPUs, which will be open for reservations and delivery at the end of 2024. And right now, they also have some of the best pricing and, more importantly, availability for very powerful GPUs like the H100, the A100 80 gig, and a few other configurations of GPUs. And frankly, I like their pricing because with Hugging Face, it's great, but you're still kind of limited by Amazon AWS's spot pricing. And Amazon spot pricing for GPUs is kind of ridiculous. And what's nice with Hyperstack is their on-demand instances are reasonably priced, and the way that they step you through the process is pretty interesting. So I'm just going to show inference across 2 GPUs for Mixtral 8x22B with a 4-bit quantization, but let me show you how you actually would set this up and why I prefer this and the feature set they've kind of selected. Granted, they're not trying to create a bunch of wild orchestration. Amazon has so many features, and even Lambda at this point has so many features that they occlude the core features of just how easy it is to set up a GPU, do some basic networking stuff, and expose access to a really powerful Linux machine with GPUs. So here we go. So this is what you see when you log into NexgenCloud. I have one virtual machine in progress right now, but what's cool is they just give you virtual machines and volumes. So volumes are basically persistent storage that you can move between machines. So for instance, if you've downloaded really large models or things you don't want to have to reinitialize for every machine, you can save some time by storing it in volume, and I've used these before. They're really quite fast, and the flow really works. Now, when it comes to selecting what virtual machine you want, you just have to do a few things. So basically, you have to create kind of a namespace and then also upload an SSH key, which is great because it's providing the amount of security you need if you're using this remotely, but they also make it really easy to set up networking as well, which I think is a place where AWS is pretty hard for a lot of people to use since VPCs and things like that are kind of complex if you're just trying to spin up a virtual machine for a few minutes. I'm going to set up another machine just to show you guys how this works. So you can see I have my Mixtral 1 machine here with 2 H100s, and I'm going to deploy a new machine. So we'll just call this Mixtral Demo. They currently have 2 availability zones, one in Europe and one in Canada, at least for the H100s. And right now, their pre-configured systems are priced really well. So you can do CPU only. There are a number of options with A100, 80 gigs over PCIe or NVLink, depending on what you're going to do. Obviously, the NVLink options are a bit more expensive. But what's cool is they kind of bias this out with what they call ephemeral storage. So this is actually SSD storage that's really fast, that they include as part of this pricing that you actually don't have to pay extra for. So again, it's baked in, it's different than a volume. And what's cool is it's a great place to download models and other big things, or even to pull things in from your persistent volumes. And this is something that you don't really get on Amazon or Lambda. These are features they charge a ton of money for. And even when it comes to options like Vast AI, the issue there is, although there are certain machines that have lots of storage, many times those are fully rented, or their pricing goes through the roof because they want to utilize all that. And what's great is you get almost 6 terabytes of just ephemeral storage with some of these options. So just for demonstration, I'm going to set up a L40 machine here. Right now, you can see I have one virtual machine at $1.40 an hour. I'm using Ubuntu 2204 LTS. I have a key pair selected, which I'm obviously not going to show you guys. You also have the option to expose the public IP. And what I also like is there's some clever, simple features like having a callback URL, which will basically just notify me if anything happens on this VPS. You also have the option to auto-install Jupyter Notebooks if that's how you like interfacing with your LLMs. And there are also Cloud init scripts, which I've written one of these, and I'll be including that in the description so you guys can save a few dollars just by not using as much time initializing kind of the base state of your GPU machine. So it's then as simple as just clicking deploy, where Hyperstack will start provisioning. And as you can see here, I have the Mixtral demo instance with the Ubuntu server with CUDA already installed, so you don't have to worry about having to go through that install process. It'll take a few minutes, but soon enough, you'll be able to log in, and this will be instantly available. So if you put a lot of time into setup, or you finally got a model loaded just the way you wanted, but you don't want to have to be billed for it while you're sleeping or you're going for a walk, another great feature of Hyperstack that I think is really underrated is called Hibernate. So if you just go and select Hibernate this VM, it'll tell you that your public IP might change, and yes, that you will not be billed, but that also your VM data will kind of be, and that the startup might take a few seconds, and I've been using this a ton over the last few weeks. And it's as simple as hitting Hibernate the VM, and now it's hibernating. So now I want to hop over into my pre-configured dual H100 machine and show you guys how well Mixtral 8x22B works. Now again, what's interesting here is just how big this model is. So this model is large enough that you actually need, even for a 4-bit quantization, basically 80 to kind of 85 gigs of VRAM. And fortunately for you, I've already set this up. And what I think is interesting is there are a few different options for how you can split VRAM across these GPUs. But you'll see here when you set up the model itself, that there's this option for device map auto, and there's also one called low mem 0, which will actually bias to everything except the first GPU. I've found it the best, that's simply enough, and this is a marvel of GPU infrastructure in this day and age. I found that basically auto is always the best choice because it'll just try to balance between the two GPUs. And balanced low 0 also works quite well, but I found for my use that with my own GPUs, where I have 4 4090s, it works a bit better because I also don't have 2 H100s that have 80 gigs of RAM each. So obviously we're not fully utilizing these. The tokenizer and model are already loaded, and I'll include kind of the script I use for that below as well. So right now the prompt is, who is Elon Musk? And I'm really kind of curious to see what this 4-bit quantization of Mixtral 8x22B will give us. It's relatively fast for me with these 2 H100s. The inference time is roughly around 30 seconds for 200 tokens, which granted is kind of slow, but it's been a while since I've done stuff on a VPS. So let's see what we get. So you'll see over here that we get a little spike in GPU utilization. The memory stays the same because we've already loaded the tokenizer and the model in. And you'll see here that this Python process, which is our inference, is using around 50% of the memory available on each GPU. And this is what we got. So we asked, who is Elon Musk? And we got Elon Musk is currently the world's richest man. He is the founder and CEO of the world's largest and most innovative companies like SpaceX, Tesla Motors. Then it explains a bit about SpaceX, mentions sort of his age when he achieved certain milestones, and starts giving us kind of a story. So I want to ask kind of a more general philosophical question, and we'll see how this model does. And what's interesting is with this auto setting, you can tell that it actually will sometimes trade off between which GPUs it actually is running the full tokenizer on. So that initial spike is generally what that is. And here we go. So I asked kind of a Douglas Adams-esque question about prompting to write a short poem about why 42 is the meaning of life. And this is what we got. So the meaning of life is not as mysterious as people say. 42 is the answer. It's the only known way. When you find the answer, you'll know what to do. The answer is 42, so the answer is true. We don't know why it's the only way. We don't know if there's a better way. And it just kind of keeps going. So this is actually pretty impressive, at least in terms of prose. Now I want to ask a question that'll really give us a basis as to whether or not this can handle multi-step reasoning and more complex questions. So this question is an example of multi-step reasoning that in theory is impossible. So obviously there's a certain number of tea bags. I say there's a certain number of times I can use each of them. And in theory, there's no way I should be able to make 20 cups of tea with this number of tea bags given the conditions. However, let's see if it suggests kind of an alternative or if it understands that this also isn't possible. So here it says, I have found that it's best to only drink tea in the morning if I'm going to make tea and only drink tea in the morning with 1 tea bag. Then I don't want tea again in the afternoon and can drink 4 cups of tea. So it understands that if you use 1 tea bag once for longer, you're getting a stronger tea, and that the effect is it gives you more energy. And we got more of a poem here, which is kind of interesting. And it says, I hope it helped, and it gave us kind of a assistant type prompt. Now, I will say what's interesting is there is not a instruct fine tune yet, and this actually might be the next project I work on with this GPU time from Hyperstack. And I'm actually pretty excited to be doing some fine tuning of Mixtral 8x22B with some of their GPUs because there's so much stuff I want to do. And curiously, this model is so big, there's really not a ton I can do with my own GPUs at home, at least as fast as I could do it with Hyperstack GPUs. For instance, I could wait a few hours with 8 H100s as opposed to days with my 4090s. So my next question is, give me an example of a novice and advanced implementation of a Mandelbrot set Python function for a fictitious programming assignment. I like asking programming questions, but what's cool here is this question goes a little bit deeper. So it asks if it can give me what it thinks is kind of a sloppy or longer-winded, maybe harder to understand implementation, and then also an advanced implementation. So it's gauging kind of what its lazy ability is, where it's thinking kind of faster, and what its advanced implementation is that it's in theory most sure of and most concise. The other thing is it has to understand that I'm asking this a question for a fictitious programming assignment. So it also has to understand that this is still a problem, which is just a Python function that generates a Mandelbrot set, but it's not a real assignment. And however, sometimes models will struggle with this because they say, oh, it's fictitious. The function doesn't actually have to be real. But let's see how Mixtral 8x22B responds. All right, so it took a few tries and we had to kind of coax this out, but we actually got a really great result here. Granted, this is probably like the 4th try. And this is what I was hoping we would get with Mixtral. So initially, since this is not an instruct model, the model will wander a bit. For instance, there was one time where we prompted this and it thought we would want it in the format of Stack Overflow answer or a paste bin answer, which was kind of funny. And what's funny here is, although we do have 2 valid functions that work, the initial bit here is it's fictitiously walking through a fictitious scenario where we paid someone for the solution to this assignment. And I guess Rami is an AGI because he knows how to do this. So what's funny is he said, you must be the student of the 95475 course for the fall of 2005 semester at Ottawa University. So it's ironic it picked a Canadian university, but that's interesting. And this is also what comes with a relatively not aligned or censored model. So it says that the professor was so much afraid of internet plagiarism, and I hope you know that plagiarism. So basically it's telling us that since we told it it was an assignment, it's a little bit confused because it thinks we're asking to get this without solving it ourselves. But obviously this is a fictitious scenario. And obviously if you're learning CS, I think the best thing you can do is to not use AI tools, but that's for another video. So now it walks us through the wiki and it goes through the terms of this exchange. So it says, here's how it can work. I can give you the answer, but I'm too lazy to write the code now. Unless you pay them for it, they get a copy of all the other answers so they can resell those as well. Or you give them a credit card number, which is kind of funny. Again, what it's telling us is that it's so good that it will not plagiarize, it will give us a novel solution, but that technically we're still not working for this. And it says, cool, but if you do that, I can explain how to make such a function and how the professor will judge it to be novel and advanced, or novice and advanced. So it kind of interpreted this as us wanting two different options that we could use in our solution to either look like we wrote it or that we didn't write it. This model assuming, it seems, that a more novice solution would be more believable than a perfect one from kind of a novice computer science student. So it does give us two functions here. We have two different functions called complex iteration. Of course, this entire function here is just a comment. But what's interesting is in the advanced pseudocode, which still roughly follows kind of a Python format, this is what we get. So we get kind of an explanation of the math going on, which I had an assignment just like this in college, and the math here roughly checks out, no major problems. And then they give us two different iterative options for this. So again, saying that this is a basic algorithm, we didn't worry about the speed of computation. A novice would get away with it, but basically saying if in an advanced scenario, this would not be the fastest. Then saying it does the exact same thing with the second function, except by reading the source of the new function, it would be hard to understand what it does because it's just less verbose generally. So this is pretty good. I think what's interesting here is this is a major hallmark of a model that's in very raw form, which is clearly what Mixtral 8x22B is. We've seen some examples of prose, we've seen some examples of programming, some rough examples of multi-step reasoning, and obviously the model is curious as to what it is. It's curious if it just wants kind of a role-playing scenario out or if it just wants a specific item. With models like this, prompting with things like prose or poem or solution in the format of is a great way to kind of coax better information out of them. And really what we can hope for is getting a instruct version of this in the near future. And in theory, we wouldn't get that much better performance if I was running the full model, but if you want to see me run the full version of this with like 8 H100s, or I'll probably do it in A100s to save a little bit of money, please let me know in the comments below. There will also be a link to Hyperstack so you can learn more about them and kind of why I use them and why they're my go-to cloud. And again, if you want to see me do other things with really big GPUs that I can't do with my RTX 4090 machine, I admittedly have just put far too many resources into, please let me know in the comments below. So as always, I hope you learned something in this video. If you like this video, please like, subscribe, and share, and we'll see you in the next one.